Okay, in this video we're going to talk about establishing trigonometric identities. An identity is an equation that you want to show is true. Now, it has a left-hand side and a right-hand side, and you have to remember that you can either work with the left or you can work with the right, but you never work with both of them at the same time. So you often pick the side that looks the most complicated and try to simplify it. So I'm going to take this left-hand side and start by simplifying that. So I've got cosecant u take away cotangent u. Okay? And what I want to do is I want to simplify this and show that I get the right-hand side. Well, cosecant u is, we know, 1 over sine u. And cotangent u is, well, that's cosine u over sine u. And now I can see that these have the same denominator, sine u. So what I'm going to do is I'm going to write this as 1 take away cosine u over that common denominator, sine u. Okay, and at this stage we're going to do something that is really, really common with trigonometric identities. And it's an algebraic technique that I thought would be it'd be useful for us to try an algebraic problem that illustrates that and then come back to this. Okay, let's do that now. Let's go ahead and simplify the following expression. So this is 3 over 5 plus root 2. What I'm going to do is I'm going to multiply top and bottom by what's called the conjugate of that denominator. And it's 5 minus root 2. Okay, so top and bottom by the same thing. And I'm going to leave that numerator as a product, 3 times 5 minus root 2, in the hopes that we get cancellation in the next step. Now, what have we created in the denominator? This is a plus b times a minus b. And we know in algebra that a plus b times a minus b, we know that's equal to a squared take away b squared. Okay? So in the denominator it's going to be 25, there's your a squared, take away b squared, and root 2 squared is 2. So now we've got 3 times, let's see, 5 take away root 2 over 23. Now in this case there's no simplification because 3 doesn't go into 23. So this would indeed be my final answer for this problem. Let's go ahead and see how this applies to establishing trigonometric identities. Let's go back to our problem. So we have 1 minus cosine u over sine u. So I'm going to multiply by the conjugate of 1 minus cosine u, which is 1 plus cosine u. Okay, top and bottom by that. And what happens? Well, the numerator is a minus b times a plus b, which is a squared minus b squared. So it's going to be 1 squared, take away the square of cosine. And I'm going to leave that denominator factored. That is as sine u times 1 plus cosine u. And now, why have we done all this? Because there's an identity that gets really commonly used in when you're establishing trig identities. And it's that sine squared u plus cosine squared u. As we know, that's equal to 1. Now if you subtract the square of cosine squared from both sides, you get this. Sine squared u is 1 take away the square of cosine. And that's what we have here, right? 1 take away the square of cosine, which is, according to this, the square of sine. And we still have in the denominator sine u times 1 plus cosine u. And now you can see why we left that denominator factored, that is as a product, because sine u is going to cancel, because it's multiplication, with the sine u in the numerator. And we're left with just sine u divided by 1 plus cosine u. Okay? And we're finished because we showed that the left-hand side is equal to the right-hand side, sine u over 1 plus cosine u. Okay, and that's how you establish trigonometric identities. Let's go ahead and see another example, and we'll have another algebraic technique that we're going to employ as well. Let's do that now. Okay, let's establish the following identity. Cosine theta divided by 1 minus tangent theta plus sine theta over 1 minus cotangent theta is equal to sine theta plus cosine theta. As I mentioned in the previous example, what you typically do is start with the more complicated side, clearly the left-hand side again. Okay, so you take that cosine theta over 1 minus tangent theta plus sine theta over 1 minus cotangent theta. And what I'm hoping to do is simplify this left-hand side enough to get it down to the right-hand side, just like before. And as we did in the previous example, we're going to express tangent of theta and cotangent of theta in terms of sines and cosines. So this is going to become cosine theta over 1 minus, okay, it's going to be sine theta over cosine theta, okay, and then plus, it's going to be, well, sine theta over 1 take away cosine theta over sine theta. Okay, now at this stage, again, there's another algebraic technique that's going to be really useful. So let's do a problem that's going to show us algebraically what to do, and then we'll come back to this one in a second. Okay, let's try this one. So this is an example of what's called a complex fraction in algebra. So a complex fraction is a fraction where you have little fractions within it. Okay, so I see 4 little fractions in this larger fraction. And what you want to do is, to simplify a complex fraction, you want to identify what I call your little denominators. How can you identify little denominators? Well, by little fraction bars. So what are the little denominators? Well, a, b, a squared, and b squared. And the LCD of all the little denominators is a squared, b squared. What you then do is you take that a squared, b squared, and you multiply top and bottom by that. So a squared over b squared over 1, that's for the numerator, and the same thing for the denominator. A squared, b squared over 1. Okay, this is a very common algebraic technique. Okay, so in the numerator, because it's addition, you have to distribute this. So when you do so, that a is going to cancel with one of these a's, and you're going to get a b squared, and then plus, right? And now the b is going to cancel here to give you a squared b. And in the denominator, well, you're distributing because it's subtraction again. But now a squared goes into this, and the a squareds cancel, and you're left with just b squared times 1, which is b squared. And then take away, now the b squareds cancel, and you have a squared times 1, which is just a squared. Now what we're going to do is factor both the numerator and the denominator and hopefully get some simplification. So from the numerator, I can factor out an ab, and I'm left with b plus a. And the denominator, I see that's a difference of 2 squares. And that's b plus a times, well, it's going to be b minus a. And then finally, the b plus a's are going to cancel, and you're left with just ab divided by b minus a. Okay? So that's how you simplify complex fractions, is you multiply by the LCD of all the little fractions to clear them. Okay, let's go back to our trig identity and see what we can do now. All right, we are at this stage. Now, do you see the little fractions? Absolutely, right? There's one right here, and there's also a little fraction for the second term over here. So I'm first going to clear the little fraction in this fraction, and then I'll come back and clear the little fraction over here. Well, what's the LCD for this one? Clearly just cosine theta, right? So I'm going to multiply top and bottom by cosine theta. Now you can think of it as cosine theta over 1, so I can just write cosine theta in the numerator, but in the denominator I can write cosine theta over 1. Okay, and let's see, for the second fraction, what's the LCD? Well, it's going to be, looks like sine theta, right? So sine theta, and then let's write the denominator, let's write that as sine theta over 1. Okay, in the numerator, well, I get cosine squared theta. And in the denominator, I'm going to distribute because it's subtraction. What do I get? Well, cosine theta times 1 is cosine theta. Take away. Now the cosine thetas cancel. That's the whole point, right? To clear the fractions. So cosine theta take away sine theta. And for the next one, same thing, right? You're going to get sine squared theta over, well, sine theta times 1 is sine theta. Take away. Now the sine thetas cancel, and you've got cosine theta. Okay, now, unfortunately, these denominators are not the same, right? A take away B is not the same thing as B take away A. However, what you can do is you can note that you can simply interchange the order of sine theta and cosine theta, and that'll generate a -1. And when you do that, you're going to take that -1 that's generated and put it right there. Okay, so let's go ahead and do that now. So it's going to, the first term will remain the same. Cosine squared over cosine theta minus sine theta. Actually, why don't we, on a new sheet, we'll just write this whole thing and show algebraically what we're going to do from there. All right, let's do that. So cosine squared over cosine minus, so cosine squared over cosine theta minus sine theta, right? That's what we had. And the next one was plus sine squared theta. This is what we just had on the previous page, over sine theta minus cosine theta. Okay, now what we're going to do is we're going to, like I was mentioning, we're going to change the order of these, and that's going to bring us a factor of -1. So cosine squared theta divided by cosine theta minus sine theta, okay, plus, let's write that out first, sine squared theta over, okay, -1 times cosine theta minus sine theta. That's a little trick you can play in algebra. You can always take a difference and switch the order. See that? Sine theta take away cosine theta. I change it to cosine theta minus sine theta, and you can always do that, but it generates a factor of -1. Now that -1 is I'm going to take that and I'm going to change this to subtraction. So I'm looking at cosine squared theta over, well, cosine theta minus sine theta minus, okay, sine squared theta over cosine theta minus sine theta. And now the denominators are the same. So it's cosine squared theta minus sine squared theta over the common denominator, cosine theta minus sine theta. And now we're in luck because the numerator is a difference of squares. So that numerator is going to be factored as cosine theta plus sine theta all over, cosine theta plus sine theta times cosine theta minus sine theta. Okay, so that difference of squares became a plus b times a minus b over the denominator, which is cosine theta minus sine theta. And now, because this is a product here, this factor cancels with that factor, and you're left with cosine theta plus sine theta. Now, a long time ago, right, we started with the left-hand side, and this is what we got. Let's go back and double check that indeed we wanted to get cosine theta plus sine theta. Let's go back to the original. And where was that? Yeah, we wanted to show it was sine theta plus cosine theta, and indeed, that's what we got, cosine theta plus sine theta. Okay, so that's how you go about establishing trigonometric identities, and it's very important to have your algebra skills down. And in this video I presented a couple of really common algebraic techniques that are very useful for establishing trigonometric identities. Okay, until next time.